welcome to this class. For today, we're trying to solve the second sample problem under the concept of perhaps the course known as hydraulics and hydrology. So the question goes below. So write down the question as I dictate. The question says a rectangular open channel has a width B of 4.5 meter and a slope of 1 vertical and 800 horizontal. Find the mean velocity of the flow V and discharge Q when the depth D of water is 1.2 meters. If C is the Chelsea formula is 49 in SI units. So that question is about 12 marks, right? So how do you solve this question? First task in science, after reading out the question, your first task in science is to what? Write out what you are given. So what am I given the question? So first task, write out the given. What are you given? First is first. From the question there, I am knowing that a rectangular open channel has a width. So I'm given width there, which is my breadth. Let's say, so I'm given the width, which is going to be B as what? 4.5 meter. Next task there, and a slope of 1 vertical to 800 horizontal. Now look up. When it comes to slope, I'm hearing slope. I can't just write out slope there. The real name for that slope is called bed slope, right? So I'll call it a bed slope. So I have bed slope. That's known as S naught. This is called S naught. Bed slope is represented by S naught. So width is represented by B. Bed slope is what? S naught, which is what? 1 vertical and what? 800 horizontal, as given in the question below. Next task is that the question says find the mean velocity. So I'm looking for mean velocity V. So mean velocity is unknown. Velocity, that's V, is unknown. Next task is that and the discharge Q when the depth D is 1.2 meter. So I'm looking for discharge, that's Q. In last class we talked about discharge, right? It's also called volume flow rate. So I'm looking for discharge there, Q. Discharge, that's Q, is unknown. Why I'm given the depth, that's D, to be 1.2 meter. Finally, I'm given the Chelsea formula, that's C. That Chelsea formula there is a constant value, that's 49. So I'm going to Chelsea formula, that's Chelsea formula, which is 49 SI units. That's like this is all I'm given in the question. So my task here is to look for discharge and depth. Mean velocity and discharge, and we're good to go. Right? So I haven't given all these parameters. My next task is to check the uniformity of the given parametric unit. So after listening out what you are given in science, your next task is to check is your unit the same. Obviously, I'm having meters, so this unit are the same. I'm having corresponding parametric units. So when you are done checking your unit, your next task is to start by answering what you are told to do. So my first task is I'm looking for mean velocity and what discharge. Let's start with looking for mean velocity. Now look up. At this point in science, you don't say you don't answer question as per maybe. Not in the question, we're taught to look for mean velocity first before discharge. In science, you can look for discharge first before what? Mean velocity. Don't say because I'm given mean velocity first, then I look for mean velocity first. No. At this point at this level, you don't say I'm given this one first, so I look for this one first. No. You can look for discharge first, then you move on to mean velocity. But in this case here, I will likely start with what? Mean velocity. So at this point here, solution. At this point here, looking for calculating for mean velocity, which is V, right? That's V. Record that mean velocity V is equal to C square root of RS naught. So the formula for calculating mean velocity is equal to V, which is equal to C. This C is called the Chelsea formula, which is 49 here. I'm done. Square root of R. What's R? R is called the hydraulic radius, please. Note that. R is called hydraulic radius. Why this S naught is called what? Base loop. Look up. I'm looking for V. I know C. Constant. I know C. No problem. I don't know R, but I know S naught. So for me to look for V successfully, I need to know three things. What? I need to know C. I need to know S naught and R. For this case here, I don't know R. So look for the value for R. After looking for the value for R, put R here and look for V successfully. So my text says look for R. And we said R is what? Hydraulic radius. Before I look for R, let me show you the diagrammatic expression for this question. If you read this question very well, the question says a rectangular open channel. So it's a rectangle. So I'm having a rectangle first. Look up. I'm having a what? A rectangle, as in this case. But what? Open channel. Let me try to explain this concept of channel, open channel for you. Have you ever passed through a gutter? Perhaps some gutter are circular in nature, right? Some water pass through some like paths to where water flow are circular in nature. Some are rectangular, right? Some gutter are rectangular that it will have maybe something like this. So water will pass through this way. Water will be passing like this, like just imagine it. So this question is saying a rectangular open channel. So here is open, right? So where you can just pour water, you can just pour water here, and it will continue to flow. So this rectangle is open. So I'm having a rectangular open channel, as in this case. So I'm given that the breadth, this is the breadth B, 4.5, and this is the depth D, which is what? 1.2 meters in meters. This is like diagrammatic expression for this question. Now look up. I'm looking for first task. I'm looking for what? Radius, hydraulic radius. So R, hydraulic radius, is equal to the area of the figure below, above, all over the perimeter of the figure. Now your task now is that, can you remember the area of rectangle? Can you remember the perimeter of the rectangle? In this case here, I have ignored this one here. So to find the area of a rectangle, we know that is what? Length times breadth, right? On this case here, I'm having just depth and B. So it becomes what then? B times what? Breadth. Depth. That's it. So all over perimeter is what? Is like the sum, the addition of all the what sides of the rectangle. So add this plus this. Observe that this to this is 1.2. Of course, here to be what then? 1.2. Observe that this one is not there. If it was there, I will add 4.5 and I'll put 4.5 here. But in this case, it's not there. So I'll add 1.2 plus 4.5 plus what there? 1.2. If it was that this one here was not open channel, we are told that it's open channel, so I will ignore this one. Instead of putting 4.5 here, I will ignore it. So I'll have something of this nature here. So my hydraulic radius, which is R, our depth is what? 4.5 multiplied by depth is what then? 1.2. All over, I have 1.2 plus 4.5 plus 1.2. If I multiply my numerator, I'll have 4.5 times 1.2. I'll have 5.4 all over 6.4. Am I correct? 1.2 plus 1.2, that's 2.4. 2.4 plus 4.5, that's 6.4, right? Check. 1.2, that's 6.9. Sorry, 6.9. 6.9. Divide these two to get your R hydraulic radius. That's 5.4 divided by that value there, I'll have 0.78 in what? In meters, radius in meters, because I'm dealing with meters and meters. So in meters. So it means that I have known this one now. So look up now. For me to get mean velocity successfully, I need to know three things. Number one is what? C. Did I know C? C is given. No problem. R, I know R now, which is this. And S naught is what? This value here. Now for your S naught, it's quite simple. I'm having one vertical, 800 horizontal. Express this one as 1/800. That's the idea. So if I take this one as 1/800, if I divide 1 by 800, I'll have 1.25 times 10 to the power minus 3 as my value for minus 3 as the value for my S naught. So it means that my mean velocity V now is equal to C. What's C? That's 49. The square root of hydraulic radius R, which is what? 0.78. Multiply this guy here by S naught. What's S naught? That's 1.25 times 10 to the power there minus 3. As in this case here. Multiply this one first. So my mean velocity V is equal to 49 square root of, multiply this guy here by 0.78 per se times 1.25, that is minus 3. I'll have 9.75 times 10 to the power minus 4, right? So take the square root of this value. So mean velocity V is equal to 49 square root of, 49 times, take the square root of this value, square root of my answer there, I have 0.0312, multiply the 2, my final answer there becomes V, which is mean velocity, is equal to 1.53, velocity is what? Measured in what? Meter per second, so I have meter per second. So I have gotten my value, I have gotten my mean velocity. So next task now is calculate for what? This charge. So calculate for this charge. Calculating for this charge, that's Q. Recall that this charge Q is equal to what? AB, area times velocity. So I'm looking for this charge. I need two things. I need area and I need what? Velocity. So it means that I know velocity and area. Check. Do we know area? Of course, yes. What's our area here? Area is what? Observe this area, which is 5.4. Next up, velocity is what? This one here. So you can look for this charge in this case now. So it means that this charge Q is equal to area. Area is what? 5.4. Multiply by velocity, which is what? 1.53. Multiply the two. This charge Q is equal to 5.4 multiplied by 0.53. I'll have 8.26 meter cube per second as my value after looking for my discharge for this given question. So if you found this class helpful, do well to like and leave a comment in the comment section below. I'll reply you as fast as I can. If you have any question, do well to put it in the comment section, or perhaps you can check the screen here and see my WhatsApp number, then check me out. Alright, see you in the next class.